The doors are closing. Train departing. Please hold on.
Welcome to a new episode of MAX101. Today we're going to be talking about the different braking systems used on the train. The trains themselves have several different braking methods, but before we really get too far on this, I would recommend watching episode 10 on propulsion and braking before getting here so that you know what the handle itself looks like and what the braking steps are. Now the MDH of your train, or the motoring drum handle, which I talked about on episode 10, when that's used to move the train, well, as soon as you start getting into the propulsion steps, it draws power from the overhead wires. And these overhead wires go back to a substation. The substation buildings power the overhead wires for several stations or several blocks or whatever. And this is what's giving power to those wires overhead. Now, when the power itself goes out, then you can't drive the trains forward. But let's say the power's running and everything is fine. When you move the propulsion, when you move the MDH up into the steps, it draws a certain amount of power from those wires. It goes through your train and powers the motors to propel your train forward. And so as you do that, it's drawing a certain amount of power and propelling the motors forward, and that gets your train moving. Now, as soon as your train gets above about 3 miles an hour, the friction brakes click off. Friction brakes are a hydraulically powered brake that'll click on and off. They're very audible on the type 2s and 3s. The friction brake is what's clamping to stop the trains. So again, once you get below about 3 miles an hour, it will do quite a bit of work to get those wheels to a stop. It's not the only thing. There's also a track brake that will press down onto the track that will pretty much plant the train to a stop. Those are more noticeable on the type 1s. When you're coming to a stop and then all of a sudden it feels like the train just kind of plants itself onto the tracks, that's the track brake dropping down. Here is a massively inefficient way of stopping a train. Take a brake and clamp it down onto the rails and grind the train to a halt. Well, guess what? The trains here do not do that, thankfully. They use what's known as dynamic braking. And basically what this does is it takes the power from the trains and it basically does the exact opposite. It removes the power from the motors by first turning them into generators. So basically manually turning the motors in such a way to where it's basically removing the power from the motors at the same amount. So as you pull your MDH down through the braking steps, it's drawing the power away from the motors to stop the train. On the type 1s, this energy that's used to stop the train, that's it. It just gets wasted away as heat. And so as you're slowing the trains down, it just wastes all the air as heat, or wastes all the energy as heat. It still gets your train to a stop, but it's not great. Now, starting on the type 2s on, there's a system known as regenerative braking. Basically what this does is it takes the power, so you draw some power in to your train by moving the train forward. But when you want to start braking, what happens is it redirects the power from the motors, and you lose the power. It turns the motors into generators, and in doing so, it's pushing the power into, instead of wasting it all as heat, it takes the power, pushes it through the rails, and goes back to the substation. So it takes the power and returns it back to the source. That way, very little energy is wasted. You draw some power, it goes to powering your motors, but when you actually begin to brake using the braking modes, it redirects the power through the rails and back to the substation. You don't lose much energy doing this, and it's not all wasted as heat like on the type 1s. Now, the way the circuit is all done is you have your catenary wires overhead. Now, this is the actual wire that goes overhead. This is what's supplying power to the train. Now, when you draw power from the substation, it goes from the overhead wire through your little connector arm. These connector arms on top of the trains are known as pantographs. Now, it'll go through the pantograph, through your train, and through all of its electrical equipment, and it returns through the rails. So all the electricity is returning through the rails, and so that's your circuit. You have your substation, your wire, your train, and then it returns through the rail. So that is how the actual electricity portion is. Now there's always a little bit of low voltage in the rails. Now I don't think there's ever been a report of somebody being shocked while touching the rails, but it would be the best idea to not touch the actual metal rail part, because there is a low voltage circuit being powered, and this is how your signals and things are powered, is through this low voltage return circuitry stuff. So when you use regenerative braking, it takes the energy and returns it through the rails, which eventually ends up at a substation somewhere. If you're lucky enough to have an electric car, they also mostly, I think they all use regenerative braking as well. But it doesn't return to a substation down the road or anything. Your car is powered by a battery. And so as you move the train forward, it draws power from the battery to propel the motors forward. But as you put on the brakes and stop your vehicle, it takes that energy and pushes it back into the battery to recharge it. It doesn't recharge it all the way, because there's a very little amount of power that will just have to be wasted, because it's very hard to have exactly 100% perfect efficiency. So some of the energy is wasted, but a pretty fair amount of it does go back into the battery and it recharges it. So it's the same kind of deal here. The energy used to power the train forward is being pushed back to the substation when you apply the brakes. As you brake harder, it pushes more energy away from the motors. And as your train drops below 3 miles an hour, 2 other braking systems click on. Because if you're just slowing your train using regenerative braking, it works until you get to a slow enough speed, and then because of the weight of the train, it makes it hard to actually come down to a complete stop. So you'll just be rolling forward until you lose enough energy from gravity, and you'll stop. So the friction brake clicks on and clamps the wheels of the train, and the track brake will click on to stop the train on the tracks. And again, the friction brakes are an audible click when you drop below about 3 miles an hour. It's an audible click on those type 2s and 3s. Now there's a really easy way to tell which friction brakes are on or not. If you go outside the train, you'll notice these red lights that'll be on outside the train. When the red lights are on, that means the friction brakes are on. So if your train is moving and these red lights are on, that is a bad thing, because that means your friction brake is on even though you're moving. As soon as you begin to move, those friction brakes should click off above about 3 miles an hour again. And that's it. The lights should turn off, meaning the brakes are off. If a train is stopped at a station and you notice that one of them is not lighting up but the other 2 are, then you know that one of them is not working or one of them is out. A train has 3 friction brakes, one by the A driver cab, one by the B driver cab, and one for the C wheel truck in the middle. A train can still function even with only one friction brake working. It's not very ideal, but it is possible. And I'll talk about this in a couple of minutes, but there's a way to manually release the brakes so that they are like that. If they are released manually, then those red lights should be off. Now on the type 4s and 5s, the red lights are also combined with an amber light right below it. The amber lights, and this is true on all the trains, the amber lights just show you that the doors are open. So again, if the door is closed and those amber lights are on, that's a bad thing. You want those to turn off as soon as the doors close. And on the type 4s and 5s, the red lights are also right above the door lights. And there's a red light right in the middle of the train for the center brake, for the center truck brake. So yeah, it's a little bit different on the 4s and 5s, and undoubtedly the type 6s will be like this as well. But yeah, the red lights, if the red lights are on, then it tells you that the brakes are on, active, and that the friction brakes are applied. Now here's another oddity with the brake lights, and this is true on all kinds of trains. As soon as the driver keys out his train, all the brake lights turn off, even though all the brakes are still applied. So if a train driver ever keys his train out, all the brake lights will turn off. So if you go at some sort of terminus station and you get to a train, you might notice that they both don't have any brake lights on, and yet they're both stopped there. Or you might notice that one of the train's brake lights is on and the other one is not. That is a really good way of knowing which train will be leaving next. So if a driver goes in and keys his train in, all the brake lights turn on. And so that is a very good way of knowing which train is going to leave next. So if the destination signs are out or something, you can still tell just by which train is keyed in and which is keyed out. So what do you do if a friction brake is stubborn and will not stay clicked off? There are sometimes, you'll hear this happen every once in a while, but the brakes they either just will never click off, or it'll let you proceed forward a little bit and then it clicks on and stops your train. Well, what's the deal? Why is my brake doing that? Well, sometimes they have issues. They can't be perfect. But you can manually release the brakes. Now in the trains, and this is not my picture, there's a box by some of the braking units called the MRU. This is the manual release unit. This is what is used to manually pump off the brakes. So when you locate the problematic brake, you can open the MRU and pump off the hydraulic fluid going into the brake and then release the brake manually. And this ensures that it will never activate again. It will never activate until you manually do the brake. What you'll do is you'll take the train back into the yard at night and it'll probably need to be worked on and checked, and then all those will be done, and then it'll be manually, activated again, and that way it'll work again. But for the time being, you can just manually release the brake and that's it. Your train can still function. Like I said, your train can function with one friction brake on. Not a very good idea, but it can still work. So if you're just releasing one of them is no big deal. Well, that concludes our lengthy brake talk today. And what happens if a brake breaks? Well, I will see you on the next one with not mechanical stuff, not really anything having to do with the actual trains themselves. You'll just have to see what I'm talking about next time, and I will see you next time.